pH of a saturated solution of aluminium hydroxide is 9. The value of solubility product of aluminium hydroxide is, in this case, the substance that's given here is AlOH whole thrice and forms Al3 positive ion. Along with that, hydroxide ions are formed in this way. So when we want to find out the Ksp value for this, the formula that we'll use here is S into 3SQ, and that is equal to 27 S4. This would be the value for Ksp. So what we need here, we need this S value here, that we can find out with the help of the pH of saturated solution of aluminium hydroxide. That's given here, it's 9. We know that if pH value is 9, then what would be the pOH value? That would be 14 minus 9, and if you subtract 9 from 14, you will obtain 5. And we know that this pOH value is equal to negative log of hydroxide ion concentration. Now, we know that in this case, we have the pOH value, and we will solve this for the value of hydroxide ion. The concentration of hydroxide ion would be 10 raised to the power minus 5 molar here. And with the help of this hydroxide ion concentration, we can find out the value S. And we know that here 3S is equals to 10 raised to the power minus 5 molar. So this S value is equals to 10 raised to the power minus 5 by 3. This is the value of S. And if it is so, we can easily find out Ksp value. That Ksp would be equal to 27 into 10 raised to the power minus 5 divided by 3 raised to the power 4. In this way. And if you solve this, you will find out this is 1 by 3 into 10 raised to the power minus 20. This is Ksp value. And we can easily choose the correct option on the basis of this value, that is option 2. And now I'm just writing here the correct answer. After this, it's a turn for question number 67. Question number 67. If equal volumes of 0.1 molar H2SO4 and 0.1 molar HCl are mixed, then the pH of resulting solution will be, and the log value is given here, log 15 is 1.176. In this case, we're just going to mix two solutions. One is 0.1 molar H2SO4, another is 0.1 molar HCl. In this case, we will find out the hydrogen ion concentration of the resulting solution, with the help of which we can easily find out the pH value. So let's see. The normality of the resulting solution will be equal to N1V1 plus N2V2 divided by the total volume, that is V1 plus V2. In this case, we know that both of these solutions have same volume. Let's assume that volume is VML. So in that case, this equation becomes N1 plus N2 into V divided by 2V. This is the formula. Now, we just want to find out the H plus ion concentration. In this case, first we need the normality of first solution, that is 0.1 molar H2SO4. The normality of this solution we can find out using its N factor. What is that? In this case, the N factor is 2. So definitely the normality for this solution would be 0.2 normal, molarity into N factor. In the similar way, if we want to find out normality of HCl, then it would be 0.1 normal only, because N factor is 1 here. So the normality of the final solution would be equal to normality of first plus normality of second, that is 0.2 plus 0.1 divided by 2, and that would be equal to 0.3 by 2 or 0.15. This is the normality for H plus ions. So the pH value is equal to negative logarithm of this value. This can also be written as 15 into 10 raised to the power minus 2 And on the basis of this, we can place this value here, 15 into 10 raised to the power minus 2. And if you take log, you will find out it is 2 minus log 15. The value of log 15 is given 1.176, and that is equal to 0.824. And if it is so, the correct answer is given in option 1, that is 0.82. I'll choose it as the correct option. After this, it's turn for next question. Question number 68. Aqueous solution having highest pH is. In the first option, it is given 0.1 molar ammonium chloride. Ammonium chloride is the salt of weak base and strong acid. Its pH is less than 7. Then if we talk about 0.1 molar solution of sodium chloride, this is a neutral salt with a pH 7. Further, we have ammonium sulfate. Salt of strong acid H2SO4 and a weak base ammonium hydroxide. So definitely its pH is less than 7. And then we have sodium acetate. And this is the salt which is formed by a combination of a strong base and a weak acid. That strong base is sodium hydroxide and weak acid is acetic acid. And in this case, definitely the pH value is more than 7 because it's a salt of a strong base. And that's why we can easily mark here the correct answer. That is salt of acetic acid and sodium hydroxide. The answer is option 4. After this, the next question is here. Question number 69. Solubility of AgCl in the solution containing 0.01 molar NaCl is. And in this case, Ksp value for AgCl is also given. That is 1.6 into 10 raised to the power minus 10. So in this case, we have the salt that is AgCl and forms Ag plus ion and Cl negative ion. We know that this AgCl, when mixed with NaCl solution, due to the common ion effect, the main source of chloride ion is this sodium chloride. And the concentration of this sodium chloride is given, that is 0.01 molar, and that is why the concentration of chloride ion is 0.01 molar. Now, if we talk about AgCl, its Ksp value is given, and we just want to find out the solubility of AgCl. So here we can find out it with the help of the Ksp value. The Ksp value of AgCl will be equal to the concentration of this Ag and the concentration of the Cl negative ion. Now let's place the values here. It is 1.6 into 10 raised to the power minus 10. The Ksp value for AgCl, and after that we don't know about the concentration of Ag positive, and for the Cl negative it is 0.01. And if you solve this for the value of concentration of silver ions, you will find out that the value is 1.6 into 10 raised to the power minus 8. And if it is so, this is the concentration of this Ag plus ion, and we can easily choose here the correct option, that is option 4. Now, after writing the correct answer, it's a turn for question number 70. Now question number 70, for an equilibrium 2A in the gaseous state is getting changed into B and C, equilibrium constant is 0.09. If 0.2 mole of A is initially taken in a vessel of volume 10 liter, then concentration of B at equilibrium is. So this is an example of homogeneous equilibrium where 2A in the gaseous state is getting changed into B in the gaseous state plus C in the gaseous state. Now in this case, if we write here the initial concentration of A, that is 0.2 mole, that's given in the question, that you have already taken. And if we talk about this B, there are 0 mole initially because reaction is not yet started. Say X moles of B are formed at equilibrium, X moles of C are formed at equilibrium. Then definitely the remaining moles of A would be 0.2 minus 2x. So these are the moles of A also. Now we know that the value of K, that is equilibrium constant, you can calculate using the simple formula, the concentration of B upon the concentration of C divided by the concentration of A square. This is the formula, and we know that the value of Kc is also given here. What is the value? That is 0.09. It would be equal to the molar concentration of B. We know that the moles of B are X divided by the volume. Similarly, X divided by the volume for C also. And further, we have the moles of A also. Those are 0.2 minus 2x divided by 10, and ultimately there is the whole square. This is the value. Now, if you solve this for the value of x, you will find out that the value is 0.06 divided by 1.6. This is the value of x that you will obtain. And if you place these values in the given equation, then you can easily find out the number of moles of B as well as its concentration also. And we can find out the concentration of B, and that would be equal to x by 10. And that x value we have already calculated, 0.06 divided by 1.6, and if you divide it by 10, you will find out the concentration of B also, and that would be equal to 3.75 into 10 raised to the power minus 3 molar. And if it is the answer, we can easily choose option 1 as the correct option. So this is the answer for this particular question.